Hello, and welcome back to Game of AI. Ever wondered how AI decides or makes choices? Like the brain cells in a computer, these decisions are driven by something called activation functions. And today, we're about to uncover the magic behind three of the most popular ones: Sigmoid, ReLU, and Tanh. Hold on to your hats, because we're diving deep. Activation functions are at the heart of neural networks, which we discussed in our previous session. They determine how much signal should be passed onto the next layer. Think of it as a gatekeeper who decides who gets into an exclusive party and who doesn't. Now, let's start with the sigmoid function. Picture a smooth curve that starts low, rises in the middle, and then settles down again. This S-shaped curve is our sigmoid function. It takes any input value, no matter how big or small, and squeezes it between 0 and 1. This is especially handy when we want our output to be in a probability format, like deciding if an image is of a cat or not. If the value is closer to 1, it's likely a cat. Closer to 0? Probably not. Next, let's talk about ReLU, which stands for rectified linear activation. Unlike our smooth sigmoid, ReLU is more of a straightforward guy. It looks at the input, and if it's positive, it lets it pass through unchanged. But if it's negative, it blocks it and sets it to 0. So, if you're visualizing it, think of half a ramp. Why is ReLU so popular? Well, it's simple and computationally efficient, which is essential when dealing with vast neural networks. Lastly, let's touch on Tanh, or hyperbolic tangent. It's quite similar to our sigmoid in shape, but instead of squeezing values between 0 and 1, it compresses them between 1 and 1. This means that it can handle negative inputs a bit better than sigmoid. So if you're trying to decide how much to tilt your game character in a flying game, Tanh might be a good choice since it can swing both ways, left or right. Each of these activation functions has its strengths and ideal scenarios. Choosing the right one is like picking the right tool for the job. Use a hammer when you need force and precision of a chisel when you need detail. But here's a thing to remember: no activation function is perfect. Sigmoid, for instance, can sometimes get too confident and cause what we call vanishing gradients, where it becomes stubborn and refuses to learn further. ReLU, despite its simplicity, has its issues too. If it blocks an input, it might never activate again, becoming a dead neuron. And Tanh, while it handles negatives better than sigmoid, still has some of the same challenges. That's the beauty and complexity of AI. It's a continuous journey of learning, refining, and adapting. As we push the boundaries of what AI can do, researchers are always on the lookout for newer, better activation functions, and who knows? Maybe one day, you'll be the one discovering the next big thing in this field. Thanks for journeying with us today through the fascinating world of activation functions on Game of AI. We hope it sheds some light on how these tiny gatekeepers help AI make decisions. And if you're as excited about learning more as we are about sharing, do hit that like button and subscribe to our channel. Trust us, you won't want to miss what's coming next.